All right. Assuming everything is set up properly, this is another floaty boat stream. um, so yesterday I had a business meeting, so we did not stream. That was Monday, and it looks like. Hold on a sec, gotta get my phone. Okay, I forgot something. Um, it looks like tomorrow, which would be Wednesday, I may also not be streaming. Let me check this email real quick. Yes. It looks like I have another meeting tomorrow. So we will not be streaming tomorrow either, unfortunately for you guys. um it's a good thing that I'm having these meetings, all in all. But it might push the streams to the weekends instead of the weekdays. We'll just kind of have to see how things unravel. But yeah, we're gonna try and adapt, and I would like to keep doing the streams. I really like enjoying, like I really enjoy showing people how to make the games that they want to make. A lot of people stop at certain points in the game development process because it gives them an excuse to not finish the game. So it'll either be like, oh, I'm not a very good programmer, so like I can't do it, or oh, I'm not a very good artist for like digital media or music, so like I'm not gonna do it. Or even if they know like programming, they'll run into a bit of math or logic that they don't fully understand, or like hasn't been taught to them in school or something. And so they'll be like, "Oh no, I don't know how to do collisions between two circles or something," which is really simple, by the way. Um, if you break it down. But anyway, I knew a guy that was like that. He used to work at a grocery store near me, and he became friends with my friend, and so we all got together to play games one time. And I talked about how I was a software engineer and how um, how I make games sometimes. And he was like, "Oh yeah, I'm a game developer too." I said, "Oh cool, what language and stuff?" And he said, "Well, I like C sharp." And I said, "Okay, well, it's not my favorite language, but game development overall is something that we can relate on, and we can still talk about the logic that is underlying in the game. Plus, C sharp, its syntax and classes and things are really similar to Java anyway. So most of the time, we know what the other person is talking about." And so I wanted to talk about game development with him. And I was talking about making like an MMO or something, and how, an MMO is a lot for like one person to undertake. And even when it's done being developed, what the problem with a single person developing an MMO is not getting the game out. It's basically maintaining your audience, because the amount of time it's going to take you to develop like a quest, whether it's a main quest or a side quest or whatever, your players can generally complete that quest faster than you can create it. And the issue that creates is that, you're constantly in development hell trying to catch up with wherever your players are in the game because they're faster than you are. And your players are going to have to wait on every update that you do in order to continue playing the game. And so a lot of players are going to lose interest because they don't want to just wait around. They want to keep playing the game. So they're gonna lose interest and they're gonna stop playing. And they'll be like, oh yeah, I'll come back later when there's more quests to do or something. I don't need to be fully up to date with the storyline. But then they forget their passwords, they forget about the game altogether because like they just get busy or something, and then they never come back. So developing an MMO by yourself is a very, 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 very hard thing to do. And you have to like keep your audience very informed, tell them exactly like what you're working on, what are some problems you're maybe running into, and try and get help um, with development any way that you can, but also keep your player base aware that like you are working on it diligently every day so that maybe some of them will stick with you and be like, you know what, I like this guy, I like his work ethic, and I enjoy the game. I'm willing to wait for updates. But if you are going to make an MMO, I highly, highly, highly recommend you get at least, I want to say like two more developers than just yourself. And then if you like, you're gonna need art probably, and so you're gonna need some artists that can pump that out. I would recommend maybe two or three of those, but just thinking about it, like if you wanted a user to be able to do 3 quests a day, well, it's gonna take you generally, I want to say like 2 to 4 hours to make a quest, like a side quest, not a main quest. A main quest could take you all day, if not multiple days, depending on what the quest is, right? Um, I'm kind of going on a tangent, but you have to think in my work day, if I work like 8 hours a day or something like that, then I can develop 4 side quests myself. And that's not doing the art or the audio for that side quest. So if I'm doing those things, then I could do maybe like 2 side quests a day. If I have someone else working on it, then I need to discuss with them and stuff and get things all synced up. And who knows, maybe that'll drop the side quests from like 4 a day that you can do to like 3 a day because of communication that you have to go through. So you can do like 3 quests yourself. So you could do like daily side quests by yourself. But then what what's going on with the main quest line? When are you going to work on that? Are you just going to give people no quests to do for an entire day while you work on a main quest? Like I don't think so, right? So you need one guy that can do like the dailies that people can do, and then you need a guy that can work on the main storyline, which will probably be you, considering it is your game and you probably you probably have a story that you want to tell with your game, right? So you will probably work on like a mainline quest um for like an entire day or an entire 2 days or something like that. Again, working closely with probably a digital artist. So that's basically like you and one other programmer dude and probably like 2 artists, right? Well, then you also want other side quests to be in the world, not just like daily side quests that people do, right? You want people to be able to go and help Sally get her kite out of a tree or something, right? But to randomly stumble upon that event in the world, not have it given to them on login or something, right? So you're going to need somebody that designs side quests in your world. And some of that comes with like NPC development, things like that too. And you may need to discuss things with them if the quest involves someone that's involved in the main storyline. Anyway, basically, you're probably going to need 3 developers to just actively update quests and add new quests to the game, and then 2 to 3 artists that basically work closely with the developers to create the digital media for that stuff. So anyway, went on a massive tangent there, talking about MMOs and why they're very difficult for indie developers to make. But I was talking with this guy that was friends with my friend, right? And we were talking about game development. I said, yeah, there's this thing that I was struggling with that I can't remember what it was now. Um, but he was like, oh, yeah, I have a super awesome game that I want to make, but I can't make it because I don't understand this logic. And I said, well, what logic are you struggling with? And he said, oh, I can't figure out how to get a collision with a circle. He says, I figured out collisions between squares, but I can't figure out how to know when something is touching a circle. And I said, well, why don't you just use the radius? And he's like, no, you don't get it. It's more complicated than that or something. And I was like, no, it's really not. You use the distance formula to figure out how far, like, I think it was circle to circle collision he was concerned about. And so you take the center of one circle and you get the radius of that circle, and then you get the center of the other circle and get the radius of that circle, and then you get the distance between the two centers, and you can use the distance formula for that. And then you just need to say, is the distance bigger than both of their radiuses? Because if it is, then they're not touching. If it isn't, then they're touching. Hey, Sam. I was hoping you'd come, man. I did say last week I wasn't streaming yesterday, but I didn't know if you caught that or not. I'm doing great, man. I had a fantastic weekend plus Monday. Even though I had a work meeting yesterday, it still went great. Like I actually had fun at the work meeting. So hope your weekend went great too. I hung out with a bunch of friends and family and played video games. So had a lot of fun. uh yeah, it's some drama. Like family drama, friend drama. It wasn't in your friend group, so it was fun watching it unfold. There's a lot of situations that I've like tried to do that. I like sit back and try and watch some drama unfold. It's like some spouses kind of arguing or something. But then it gets kind of serious, and you're like, I don't know if I can just like sit and watch this anymore. You kind of got to intervene and be like, yo, chill. Like it's not that serious. It's a friend group that you're welcome in, and you just like to chill there sometimes, but it's not exactly your like close friend group. Uh, you've been in the argument. Were you in like this argument, or are you talking about like a different time? Oh, there were two people that had like a 5-year friendship and they broke up their friend group. That's crazy, man. Yeah, I had two guys that were my friends, and one of them had a girlfriend, and they broke up, and like I think it was like within the same week, the other guy friend of our group started dating her, and the one guy got like really pissed. He's like, "Yeah, that's not in the bro code. You're supposed to wait like 2 months or whatever." I can't believe this that my friend would be dating my ex and da 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 da. It's like, it happens. Like, I'm sorry to say, like, sometimes someone meets someone in your friend group and they think that they would jive more with them. And maybe it works out, maybe it doesn't, but the fact is they're not with you anymore, and like, yeah, that's really sad, but I don't know if there's anything you can do about that, really. That's crazy. I had a girlfriend back in school that was like a long friendship with one of her friends too, and they just like, her friend didn't treat her well anymore for some reason. And so she was like constantly complaining about her friend treating her like garbage. And I was like, "So why are you still friends?" And she's like, "Well, we grew up together and da 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 da." And eventually they actually ended their friendship. And I think my girlfriend was better off with it. But, you know, for unrelated reasons, we did not work out. So going solo, being a solo player in life again. That was a long time ago too, so it wasn't like it was recent or anything. But yeah, it's crazy. You think you know somebody, you become friends after like 5 years or so. Sometimes you learn more about them, and you don't want to be as close anymore sometimes. But yeah, that's crazy. You see it in friendships, you see it in like spousal relationships, like boyfriend girlfriend sort of thing. You see it in marriages too. We had high rise in divorce in America the last probably decade or so, I think, at least around where I live. Um, but yeah, it's crazy. I think people just pretend to be someone they're not, and then you kind of figure out who they really are, and it doesn't work out so well. I'm gonna play some music. Coincidentally, it's funny that we're talking about people breaking up. I was gonna play breakup songs to scream in the car 2026, and I just liked the playlist. I was gonna play it anyway, but you know, on a related note. um, yeah. So what was I talking about? But yeah, I tried to tell this guy how to do collisions between two circles, and like he just wouldn't listen. He didn't want to be told the answer to his problem, because that would mean he could actually continue working on his game. And really, under the surface, he did not want to develop a game, which is unfortunate. Well, I don't know if it's unfortunate. It's just fake. Like, he says he wants to make games, but he doesn't really. Um, feel like I've been kind of derailed. Today, what's the goal for today? We're gonna try to show you why math matters. Um, basically, in probably college, if you were a college student, some of you might not be. You learned trigonometry, and a lot of people were like, "Oh my gosh, trig was incredibly difficult, and I didn't understand any of it." Yeah, trig is triangles. So it's really, really simple if you don't think about it too much. You have sine, you have cosine, and you have tangent. Triangles are Dorito shaped, that's all I know. They probably taste the same too. Exactly, man. So we're gonna draw a Dorito, but specifically a Dorito with a 90-degree angle. And this is called a right triangle because it makes what's called a right angle, which is an angle that is 90 degrees. Wait, you know what I'm talking about? Awesome, man. So, sine, cosine, tangent. I'm going to tell you right now, you don't need to know what these actually are, like ever, in real life at least. For mathematics, you may need to know once you enter like calculus, but even in trig, you don't need to know what they are. You just need to know how to use them. Um, Having school flashbacks. Hopefully, those are good memories, man. What's up? Who had prio? What do you mean? What do you mean by prio? I do not know witchcraft. I've heard the other guys say witchcraft, but I haven't heard anything about it. Crowny and Velia were having drama? Mm, I'll have to check that out. Okay. I'm gonna do this quick math lesson. But yeah, I should look that up later. So, we have a triangle here, right? And it's a right triangle. I should probably. What happened to my. Why is my pencil smaller? What happened here? Is it because I'm not using the brush? Yeah, that's what it is. Okay, let's try and draw this a little bit better. Okay. I'm going to try and teach you everything you need to know on just this triangle. You're going to lurk because maths are scary. That's cool, man. I mean, if you're not going to use it, you might not need to know. But it is useful in some things in life. Like, I think trig, you can use in real life. Calculus? Eh, you know? So, but yeah, I'm going to do this quick lesson because we're going to be using it in a game we're going to work on today. And hopefully, this will be a bit more complicated, a little bit more difficult for people to understand and learn because I am not streaming tomorrow. So, yeah. You know how to count to 5, so you're good? I mean, if that works, man. I'd suggest at least 10. I mean, you have enough fingers for 10. But yeah, I'll see you later, man. Alright, so we have different parts of a triangle. We have the hypotenuse, which is this side. And then we have the adjacent, or the opposite. But these terms are relative. So I want to move this kind of off to the side if I can. Okay. And then we don't, as far as I know, really have a name for like these sides. Because we only really care about the hypotenuse, which is the one opposite of your right angle. You could probably say this is like the base and this is like the height or something like that, but that's very like fixed definitions for what they are, and like depending on what you're measuring, that might not represent what it is very well. But anyway, so we know these kinds of things now. I'll explain adjacent and opposite. So adjacent means it is a side that is part of what makes the angle. So this one could be adjacent, and this one could be adjacent. And then opposite is whatever edge is not part of the angle. So it's going to be the opposite of the angle, right? So we can do a lot of different things with this. We can do the Pythagorean theorem on right triangles, right? I feel like I'm forgetting something. No, I think I'm good. Okay, so what that is like if this is A and this is B and this is C, then A squared, what is it? Is it plus? I think it's plus, right? I think it's plus B squared equals C squared. And I'm gonna Google that to make sure because I haven't used it in a while, but I'm pretty sure that's what it is. Pythagorean theorem. Yes, that is what it is. I was pretty sure, but you never know. Stream kind of makes things harder to remember and explain as well, because you're trying to think like, how do I want to say this, and like, how do I want it to be presented, and things like that. Anyway, it makes it harder to remember things, and I'm making excuses. But yes, I did forget math. um, so a squared plus b squared equals c squared. What does this mean? It means if you square this side and you square this side, then you will get the square of this side. So if I wanted to know the length of this side, when I know this side and this side, then I can just square this side, and then take the square root of what the result is, and I will get this side. And that's very useful for a lot of different reasons. Let's discuss kind of a game reason that would be important. So let's scroll down a bit. We'll make a circle here, and this is going to be kind of what our game is going to be like. So we have a circle, We have a center of the circle here. And let's imagine this is like our canvas, screen, whatever, right? Now we have this guy and he has like a gun or something, right? Pew pew. Um, so we want him to basically face wherever our mouse is going to be, right? So if I move my mouse around, um, like to the right here, I would want it to rotate to the right and face this direction, right? So what we do is we're going to use the on mouse move, and we're just going to use like the standard grid that we use in regular math to kind of explain this. So we have like our y-axis and our x-axis that breaks up our screen. So we're going to use our on mouse move to figure out what the coordinate of our mouse is, right? So given a regular kind of grid with the origin in the middle, let's say this is like 5, 5 or something like that would be like somewhere around here, okay? So our mouse is right here, and we want this character to look at it, right? Well, by default, the way that we're going to draw our character is not going to be looking at that point. We want our character normally to be facing like straight this way, and he's got like his gun, right? And then we want to rotate this image by a certain number of degrees to be looking at the mouse. So we need to rotate him this way so that he will be looking at this point, right? So let's just do that. We want him to be looking like this. And we'll imagine 5, 5 is like right there. I'll be kind of mixing that. Okay. Well, we need to know what the angle is here in order to get it to look that direction, right? Well, let's just drop a line straight down too, and you'll realize that this would be 90 degrees, right? So we'll just say 90 because some people don't understand the right angle kind of notation. So now it looks like we've done a right triangle here, right? But we don't know what the angle here is yet. We know what this angle is because it's 90 degrees, but we don't know how to get this one. Well, we know our point is 5, 5, right? So that means it's 5 from the axis, right? And it's 5 from the axis, right? So 5 from the axis would be 5 here, and 5 from the axis would be 5 here. And I'm going to change these numbers a little bit, just so you know the difference, but the math is going to be the same. So the point, let's say, is like 5, 7. And so then this would be 5, and this would be 7, right? Well, now we know this angle, we know this side, and we know this side, right? So we need to figure out what this angle is. Well, one thing that we don't know is the hypotenuse here, right? And I don't think we need that to rotate it, but we might as well check it out anyway. it's going to give us the distance between the center of our player and the mouse. And that might become interesting later. So that would be 5 squared plus 7 squared equals something squared, right? And this would be something right here. So that's 25, and I think that's like 49, right? And then we add them together, so it'd be 74, I believe. And we need to square root that. Um, Let's pull out a calculator because I don't feel like doing it myself. How do I do? Ooh, the mathematic calculator. So we need the square root of 74, which is like 8.6-ish, because it rounds to 8.60. So we know x is about 8.6. So let's just erase the x, and we'll maybe draw it a bit different. We'll say x equals 8.6. So we know this length is 5, this length is 7, and this length is 8.6 now, because we used the Pythagorean theorem, right? So that's a squared plus b squared equals c squared. So that's how you can use the Pythagorean theorem to find the distance between basically your character and your mouse, but we haven't found the angle yet, right? So it's at this point that we need to use cosine, tangent, and sine. But looking at this, we might need to get a bit creative with it. So normally we call an angle theta, and it looks like basically a circle with a line through it. So we need to think about which of these we want to use. Now, there's a saying with sine, cosine, and tangent. You can say, it's so ka and toa. And you're just gonna have to remember this. But it's really helpful when it comes to managing triangles. So you don't need to know exactly what these are, but you need to remember SOHCAHTOA in order to be able to do the mathematics that you need to do with sine, cosine, and tangent. And what these break into is the sine of the opposite over the hypotenuse. And so you get so, because S from sine, O from opposite, and H from the hypotenuse. And this is where this kind of like breaks up, right? And we talked about adjacent and opposite and hypotenuse. So what does this mean? So we need to take the sine of the opposite, which would be, oh my gosh, I'm having like a math stroke. I think this gives us an angle, right? Oh my gosh, I'm gonna have to reteach myself math. Anyway, we'll continue. We'll kind of figure it out. Might need a quick brush up on trig myself. But anyway, we have cosine. Oh, you know what? I think it's like that, isn't it? The sine of the angle is the opposite over the hypotenuse. It's either the sine of the angle equals this, or it's the sine of this equals the angle. We're gonna have to play around with it. I'm actually just gonna Google it. I have the internet, why wouldn't I? So, Toa. Ha! I got it right. So, it's the sine of the angle is the opposite over the hypotenuse. See, if you think about it for a minute, you can remember. It's only been what? Fuck, like almost 10 years, I think, since I learned this shit. Actually, maybe less than that. I'm not sure. It's been a long time, and I don't really use this very often, but it's useful in games. So, cosine is the adjacent over the hypotenuse. So the cosine of the angle is going to be the adjacent over the hypotenuse. Again, CAH, so you get ka. And then TOA is the tangent of the angle is the opposite over the adjacent. My handwriting is terrible. Okay, hopefully you can read that. And once again, TOA for TOA. And this is the key that will allow you to pass trigonometry. You can remember SOHCAHTOA, you're basically done. SOHCAHTOA and the Pythagorean theorem, that's like 90% of trigonometry. And again, you don't really need to know what sine, cosine, or tangent are. You just need to know that you use them on an angle in order to get the sides of a triangle. But you also have inverses of these. So if I believe if we kind of reverse these, I think if you do the sine inverse, which is something to the power of -1 would be an inverse. I think if we do that on the opposite over the adjacent, or the hypotenuse, because it's so, I believe that gives us the angle. So if you want to do this the opposite way, like you don't know the angle, but you know the opposite in hypotenuse, then you can do the inverse sine in order to go like the other way. Because, how am I going to explain this? Let's think about it like this, right? If you have 5x and that equals 10, right? Let's pretend that multiplying by 5 is the same thing as sine, right? So in order to solve this, we need to get rid of this 5, right? Well, to get rid of a multiplication, you use division, and you divide on both sides. So we divide both sides by 5, and we'd be left with x equals 2, right? And that gives us a solution to our problem. Well, the opposite of sine of something is the inverse sine of something. So if we have the sine of the angle equals the something over something, then if we do the inverse, then it would look like this, because the sines cancel out, equals the inverse sine of whatever this was. Because, again, we're doing the inverse sine to both sides, similar to how we did a divide by 5 on both sides, right? So we're trying to cancel this out, so we're left with the thing we're trying to find, and then we just need to add it to the other side in order to keep the equation balanced. So hopefully, basically this gets you through trigonometry, and I explained it well enough, because I get that it can be a little complicated to follow sometimes. There's a lot of words being thrown around. It's a lot of terminology to pick up immediately. But like, this logic should basically get you through trigonometry. But we're going to go back here, because this is the situation that we we needed to figure out, was what's the angle, right? We already have the sides, but we don't know the angle. So let's get this sorry, choking on my coffee. Let's get this Pythagorean theorem stuff kind of out of the way. We used that to find the hypotenuse, right? So now we need to find this angle. Well, we know, let's say, what doesn't use the hypotenuse? Tangent doesn't use the hypotenuse, right? Because we generated the hypotenuse, but I said we're not going to use it, because we had to do more work in order to find it. And if we can do less work, then I'd rather do that. So let's pretend like we don't know what this hypotenuse is yet. So we know that the tangent in its equation does not use the hypotenuse. It only uses the opposite and adjacent. Well, this would be the opposite of this angle, because it is not part of the two touching sides. So 7 would be our opposite, and 5 would be our adjacent, because it's touching the angle and it's not the hypotenuse, right? So let's check this out. If we wrote tangent of theta, which theta is the angle we're looking for, right? That is equal to the opposite over the adjacent. So the opposite was 7, and that's over the adjacent, which is 5, right? Okay, that's cool and all, but we're trying to find the angle, right? And in order to undo this tangent, we have to undo it on both sides. And what we would do to undo it would be a inverse tangent. Because like I said, inverse is like the opposite of doing the function, right? In order to cancel it out. So we need to do an inverse tangent in order to get theta by itself. And then we need to apply this tangent inverse to both sides to keep the equation equal. So we're going to get equals tangent inverse of 7/5. Okay, so now we have an equation in order to figure out our angle. So let us plug this into a calculator. And we might run into a little problem, but I think we can solve it. So if I say, oh, there's not inverse tangent on this. Yes, there is. Wow, phones are awesome. Inverse tangent of 7 divided by 5. And then we're going to close it. It says that the theta is 54.462. We're going to round that to 46. So this, depending on how how it's calculated, because we have radians and we have degrees, which is another thing I should probably explain about trig. So degrees is what you generally know angles as, right? It's like 90 degrees, 45 degrees, that kind of thing. There's another way to measure angles called radians. And computers like to measure things in radians, but we like measuring things in degrees. And there is a conversion that I'm going to show you to get from one to the other. But depending on which mode your calculator is in, either radians or degrees, your phone is going to, or your calculator, whatever you're using, is going to calculate the sine, cosine, and tangent to be a different value. Because this could either be 54 degrees, or it could be something like, well, it'd be less than 90, but more than 45. I don't know. I'm going to throw out a random number, and I'll say this could be like 2/5 radians. Something like that. It'd be somewhere around there, I think. Maybe. I don't know. We'd have to figure it out. But I believe my phone is probably in degrees mode right now. And I kind of get that by looking at these angles and just thinking, well, 54 is less than 90. This is less than a right angle. So it's reasonable to guess this is probably measured in degrees. And this is about 54 degrees right here. And so now we have our answer. How far do we need to rotate the image in order to make it look like it's looking at this point, right? So then I would just do a transformation on my canvas saying 54 degrees. However, it would be inverted on the y-axis technically, but we're not looking at that right now, in order to make it look like this is looking at the mouse. And then you'll just put this all tucked away inside of a worker function so that you never have to do this work again yourself. And then you'll just keep calling that function to change the player's sprite to look at the mouse as you move your mouse around using the on mouse move listener. So I'm going to go to the bathroom, and then I'll try to explain basically degrees versus radians. So I'm going to be back. And we'll do some more math lesson, but we're almost done. Like the math between degrees and radians is so incredibly simple. You're gonna be like, oh my gosh, we were already done before he left. So I will be back. Okay, we are back. So we just ran through a bunch of trig nonsense. How am I gonna make this bigger? What if I just go like this? I just drag this like off the window a couple times. Because we're gonna need to go over one or two other things. Okay. Hopefully that's enough room. So, degrees and radians. Basically, you have a circle, right? This circle has 360 degrees in it, right? So if we started from here and we went all the way around and back to where it was, that'd be 360 degrees, right? And then if we only went halfway, then it would be 180 degrees, right? Well, in mathematics, for whatever reason, we came up with another way to say 180 degrees, and we call it pi. specifically pi radians. All right. So pi radians is the same thing as 180 degrees. So you can write 180 degrees, or you can say pi radians. It's just two different measurement systems. You can use whichever one you like, but you have to be consistent so that you are always using radians or you're always using degrees. And that's why it's really important you set your calculator into the mode that you're going to be using. Most schools will have you set your calculator to degrees mode because, like I said, humans use degrees more than radians. So they will probably have you set it to degrees mode. And then any of the sine, cosine, or tangent functions you use on your calculator will always give you the degree result instead of the radian result. So let's just kind of look at another circle. Let's say we have this circle here, and we're gonna go from here to 90 degrees, right? So this is 90 degrees. Well, if we know that pi radians is 180 degrees, then if we want 90, that's half of 180, right? So if we take half of pi radians, then it's pi half radians is 90 degrees, right? Because we just did the same thing to both sides of this equation to get a new result, right? And that writing looks terrible. And so this would be pi half radians. It's the same thing. And then you think, okay, well, we know 360 is all the way around, right? How many radians would that be? Well, 360 is twice 180. So if we do twice of pi radians, then it's 2 pi radians. I'm just going to write r, even though usually we use that for the radius. Now I'll write rad. So it'd be 2 pi radians is 360 degrees, right? So that's your simple conversion. Just degrees to radians, radians to degrees. Like, this is all that you need to know in order to do that. And that's kind of a separate thing from what we were talking about before. And then there is one more thing that I kind of wanted to talk about. So there's going to be scenario where we know these two numbers, the opposite and the adjacent, but we need to know we need to know the angle. So we figure out the angle, but then we need to kind of make our own triangle after that that's going to change these two. So it's going to look kind of like this if we kind of draw our screen again. And we said this was like 5, 7, something like that, right? And then we had our player here that's looking this direction. And then we have this, that, this is a right angle, this is some degrees. Okay. So we're always going to know how to get to 5, 7, because this is always going to be 5 and this is going to be 7, right? That's how we get our coordinate. But we're going to get to the point where we know the angle from doing the math that we did here. And so we'll say like 54 degrees. But we don't want to go out all of this distance. We want to stop like right here for what we're trying to do, okay? And I'll try to explain when we would use this when we're going to do it. So instead, we want to stop here. Well, we know the full length of this is 5, and the full length of this is 7, right? But that's not helpful for us. We can't do any quick like division or anything in order to shorten this 5 to be here and then know what this size is, right? So we need to basically ignore the length and stuff here. But we do know how far we want to go up the hypotenuse because we want to stop there, right? So if we just completely ignore the information that we had before the angle, and then we say, okay, well, I wanted to go how far down here? I wanted to go like 6 distance between here and here. Oh, we're gonna have to cover distance too. But anyway, so we wanted to go from here to here at 54 degrees, and we want it to be a length of 6. Well, now we can use the other trig functions that have to do with the hypotenuse, because we know the hypotenuse and we know the angle. So let's look at those. Well, this uses the hypotenuse and this uses the hypotenuse. So which ones do we want? Well, we know it's going to involve the angle in it. So it's going to be the something of 54 equals, and then if we want to get this one, it would be the adjacent. If we wanted to get this one, it'd be the hypotenuse, right? So let's get this one first. So we're looking for one that has adjacent and hypotenuse and the angle. So hypotenuse, adjacent, hypotenuse, adjacent. Well, this is hypotenuse, this is adjacent, and this is the angle. And that's all the 3 pieces we need, right? So it looks like we're going to be using cosine for this one. So we're going to take the cosine of this angle equals the adjacent, which we don't know, over the hypotenuse, which is 6, right? Okay, well now we just need to do some math, right? Well, we have x divided by 6 over here, and we want x by itself. So we're going to multiply both sides by 6. So if we times this by 6 and we times this by 6, we're going to have 6 cosine of 54 degrees equals x. And then we can just plug that in our calculator. And we will say, go to the math calculator, 6 cosine of 54 is, and the result that I get is 3.526. So we're going to say 3.53 to kind of round it. And this is x, and x was the adjacent, right? We discussed that. We were trying to solve this one, which is the adjacent. So now we know the distance between here and there is about 3.53. And then we're going to do a similar thing for the other side. But like I said, we're going to need to use something other than cosine, because cosine was the one that included the adjacent, and we need to use the opposite now, right? So we're going to look for hypotenuse, angle, and opposite. So we've got hypotenuse, opposite, and the angle. So it looks like we're going to use sine for this one. So we're going to need to do the sine of our angle, which is still 54. And that's going to equal, well, so it's opposite over the hypotenuse. So the opposite is, again, going to be what we're looking for over the hypotenuse, which is 6, right? And just to clarify, 6 was from there to there, is what we were saying, not the full length. So we're looking for this one using this function. So let's plug that into the calculator. We're going to say the sine. Oh, sorry. We need to do the multiplication to get it out, right? So it'd be 6 sine of 54 is x. So 6 sine of 54 gives us 4.854. We're going to say 4.85, right? And so this would be 4.85. And that makes sense, right? Because this is shorter than this length. This is shorter than this length. And then the way that we had it before was like 7 by 5 was like the full size, right? And so this was bigger than this, and this is bigger than this. So it all seems to kind of make sense, right? So I believe we've done that math correctly, and my calculator is likely in degree mode, because we've been using degrees, and it has been giving us consistently very valid answers. But yeah, so we've now used sine, cosine, and technically tangent. We used inverse tangent, but we've technically used all of these three. And that really will get you through like pretty much all of trigonometry, is just the math we've gone over. There's one other thing I want to go over, which is the distance formula. And it's pretty simple. We have our grid, and we'll put 2 points on it. One of them will be, we'll say 2, 3. So it'd be like 1, 2. Oh, sorry. It'd be 1, 2, 1, 2, 3, right? And then that is a point here. And then let's do another point. Let's do 3, 4, 5. So it'll be 5. Let's do 5, 1. Be somewhere like here, right? So we have these 2 points, and we want to draw a line between them, and we want to know what the distance between those 2 points are if you go directly from one to the other, right? Now, you could be like, well, this minus that or something, or like this minus that would be 3. So we have like a 3 distance between here and here. And then between here and here, we have a distance of like 2, or hold on. Yeah, it'd be a distance of 2 between those two, right? So we've made this angle, and that would form a right angle. And then we could try to do like the Pythagorean theorem, right? And I believe this is where the distance formula is kind of going to come in. But then it'd be like 3 squared, which is 9, plus 2 squared, which is 4, would be 13. So then the question mark would be the square root of 13, right? Is that what I said? 9, 4, 13. Yeah, so the question mark would be the square root of 13, right? And I believe we just did the distance formula kind of in our heads there. But there is a faster way to write it. And I'm just going to Google it because I don't feel like using my brain. Distance formula. Yes. So the formula for distance is, we need the square root of x2 minus x1 squared plus y2 minus y1. I want to write that again. It doesn't really look like a y. y1 squared. So this is the distance formula. And this is exactly what we just did to figure out what the question mark was. Because we took 3 squared. Well, let's back up a little bit. We had 5, 1. So we had 5 as our y. Yeah, let's just write it out. So in our example, we have the square root of x2, which is 5, minus 2, and that would be squared. Now, writing it this way is the same thing, effectively, as saying, it's kind of hard to explain, but we know how, like, this squared plus this squared was the question mark squared, right? So we need to get a similar kind of effect out of our distance. So we have this square, which is acting as our squares here. Like, it's essentially accomplishing the same goal with what we're going for. So we have our locations squared plus, which is pretty much where this plus comes in, right? And then y2 was 1 minus y1 was 3. And that's squared because again, the square is coming in. And then that equals something squared. Well, in order to undo the square, we need to take the square root, right? Which is where this square root comes in. So you kind of see how the distance formula was made according to the Pythagorean theorem. It's just, it works a little bit different. So if we run the numbers here, I believe we should get the same answer whether I say square root 13, which is 3.61-ish. And if I write out the whole thing of 5 minus 2 squared, how do I square in this? Oops. Squared plus, I hope that's working the way I think it does. 1 minus 3 squared and we take the square root of that. I don't think it did what I wanted it to. Oh, there's a square button. Okay, let's try that. The square root of 5 minus 2 squared plus 1 minus 3 squared. Close the square root. Okay, now we get the same answer. I just wrote it differently in the calculator because it has buttons that I've never used before. So this is also 3.61. So our square root 13 here is 3.61, and evaluating this distance formula gave us 3.61. So we know that we did it correctly either way. And if you prefer using the Pythagorean theorem for this, you can. You don't have to use the distance formula, but the distance formula is going to make calculating this stuff a lot easier. And I just want to Google something. Distance formula in JavaScript. I think yeah, JavaScript already has a distance formula programmed into it. So we don't actually have to write this function ourselves. It's called math dot hypot. And it would take x1, y1, x2, and y2. Wait. No, we have to make the distance ourselves. There's a hypotenuse formula, but there isn't a distance formula. So, unfortunately, we will have to write it ourselves. But I just explained the math to you. So, hopefully you can look over this once or twice and you can figure out, kind of the basics of how a triangle works with all these functions and how you use them to solve different parts that are missing in a triangle. And then also the conversion from radians and degrees, and then creating your own triangle essentially from an angle is what we did here. And then here we were explaining distance. So yeah, I highly suggest going over what we've talked about, this will 100% get you through trig. This is like all of your trig class. There's maybe 1 or 2 formulas that they're going to have you memorize that are other than this, but this is literally like 99% of your trig class. So if you can get this down, then you'll know trig. Yes. Yes. I'm gonna skip the song. I don't really like it. Now that we've gone over the math, I think we need to jump into actually making the game. So, kind of how I explained earlier was we're going to have like a character here, and the character's going to turn to look at the mouse, right? And then we're going to have it shoot bullets towards the mouse. And then we will have enemies that either shoot at the player or will just run at the player. And then we will do a circle to circle collision between the player and the enemy to show my friend, or at least my friend's friend, that is not really my friend, that circle collisions are really simple, right? So let us get into that. I guess maybe I'll show you the collision thing real quick, just to kind of break it down for you. So we have a circle here, we have a circle here. Each of these circles have a radius, right? Well, if we were to point the radius at the other circle like this and like this, the radius is still the same length, right? So I'm just going to write it like this and delete these to make it less confusing. So no matter which way you spin the circle, your radius is going to be the same length that it was before, right? And this will probably be like radius 1, and this will be like radius 2, because they're not exactly the same. But anyway, then we also have a distance between these two, right? And we'll say like dist. Okay. So assuming that we're taking the shortest route between these two circles to go from one circle's center to the other circle's center, we know that at least this first bit here is the radius. And the first bit here is the second radius, right? I'm kind of running out of space, but it's radius 1 and radius 2, right? Are these first little bits. Because this will be the edge of the circle here, and this will be the edge of the circle there. Sorry, I'm not drawing it very well. But basically, we know the radius will be the very edge of the circle. Well, then we don't need to know what this is. We just need to know that it exists, right? Because if it doesn't exist, we would have something that looks like this, where we have our radius, and then we have our radius 2. So the distance between here and here, and here and here, there is none of this distance here, right? So we just need to know that this distance portion isn't 0. Okay, well, we know if they're grouped up like this, then this line here should be radius 1 plus radius 2, shouldn't it? Because we have radius 1 here and radius 2 here, so if we just add them together, that will give us the distance between these two, right? So if there is anything else, then we have this space. But in this current situation, there is not. There is no space between them. So if I just do the distance formula between this point, and they'll have coordinates, and we say, okay, well, the distance between them is, we'll say 7, okay? So if the distance between this circle, I don't want to draw this. Let's kind of redraw this a bit. So if the distance between this origin and this origin, if it's greater than, so if 7 is greater than the radius 1 plus the radius 2, so radius 1 plus the radius 2, which we would know these values, by the way, then they are not touching because we would have this distance area here. But otherwise, if it's less than or equal to 7, which again, we would know these values, then they are touching. Because we would be in this sort of scenario, or we would be in this sort of scenario, where we have the radius here, and we have the radius here. And so this, this overlaps with this, right? And so there's still none of this distance in this situation. And this will be true even if you like swap the positions of the circles, you're still not going to have this distance area all the way until they separate and you get a situation more like this. And that is the essence of circle to circle collision, is if you are further than one radius plus the other radius, then you're not touching. If you're closer than that, then you are touching, which is a collision. So, anyway. I believe that explains all of the math for this stuff. Yeah. And then just remember, in computer graphics, normally we have y going up this way and x going up this way. In computer graphics, y goes down and x goes right. So you're going to see some flipping stuff we're going to have to do where y isn't y, it's actually negative y. But that's the only difference as far as the graphics goes. And then I'm going to have to explain something else later. Maybe I'll do that in a different game. I think we'll make something sort of like asteroids. Mostly to explain how you would use some of this math. There is some other math I was going to bring into it, but we've already covered a lot that's going to be difficult for some people to understand. And I really do recommend just going over this a couple times and trying to follow along, see where all of the puzzle pieces fall into place. So like where the angle matches the angle, where the adjacent or the hypotenuse matches the hypotenuse, that kind of thing. Because it really is just, we have these three functions here, or these three equalities, and then we're just plugging in values wherever we can in order to complete one of these functions. And if we can complete the function, then we can use that function. And then if we need to get the angle instead of a length, then we just do the inverse of whatever we were using, right? Okay. Let's jump into the programming. I'm gonna save this and probably do nothing with it, but I might bring it up later. So we'll call it trig.png, save it to the desktop. All right, so let's open Z, and we are in our htdocs. So let's open XAMPP and get the Apache server running. Do I want to do this in modules or just do it on the page? I'll probably just do it on the page. I don't think it'll be so complicated. We need to do modules. So let's make a new folder in here. And we're going to call it, for now, we'll call it TrigShooter. How about that? And we will make, sure, save it. Let's make a new file, index.html. Let's increase the size for you guys. And then let's open it in Chrome. So I'm just going to right click the index.html, say open with Google Chrome. And then we're going to move it over here. Okay. And we're going to try to resize this in a way that makes sense. We'll open our console with Control-Shift-J in Chrome. And I believe we are good to go. So let's do a bit of HTML stuff. Doc type HTML. We're going to open our HTML tags. And let's make a title. For now, it's just going to be TrigShooter. Let's say our car set is going to be UTF-8. And then we need to open a body. We're going to make a style tag for some quick CSS we're going to do. Let's do margin 0, padding 0, vertical align top. And these are just some preferences that I like. We're going to put a canvas on the page that we're going to draw on. We're going to give it an ID of canvas. We're going to say its width is 900 and its height is 600. And then I'm going to surround these in quotes just because I like how it looks more. We're going to open a script tag so we can write our JavaScript. And we're just going to say it's text/JavaScript. We're not going to make it a module this time. So I want to know, can I start it indented like this? Because I don't like the spacing for scripts. We'll work at it and see if it is listening to my indents or not. So, first things we need to do, I want to change where the canvas is. So I'm going to say body background black so that we have a black background. I'm going to say canvas background white. And then we're going to try and center it. So let's say margin, I think like 15 pixels, auto, 0, auto, and then display block. I believe will do what we desire, and it looks like it does. So I made a white canvas, centered basically, a little bit of padding on the top, and then we're displaying it as a block, so it follows these rules. The background is black, the canvas is white, and then this is just some browser stuff. Browsers have some default CSS that I'm basically just overriding here. But yeah, that's all of the CSS that we're going to need. I'm just going to close this because I don't want to look at it. And then we can move on with actually making the game now that we have our canvas set up. So I'm going to say let canvas equal document.get element by ID canvas, because we're getting this element by its ID, which I set to canvas. Let can equal canvas.get context 2D. And if you want a better explanation of how we're setting up this game, you can go and check out the Cube Wars game that we made. I think I'll use that as sort of the basis for a lot of the games we make in HTML and JavaScript. So I would go and watch that if you're wondering what a lot of the things I'm writing mean. But if you already know, then just follow along and you should understand what we're writing. We're going to say function update, function render, set interval. We're just going to make a new function and we'll say update, then render. And we want to do this 60 times per second. And I've just combined our tick function and the set interval function that we did before into one thing. This just saves some space. It'll do the same thing. At least I believe it will. Okay, it looks like it's gonna do indentation the way it wants. So we'll just do it the way it wants, I guess. So in order to test the rendering and stuff, let's say clear rect 0, 0, canvas offset width, canvas offset height, and that should clear the entire canvas when it loops. And then we will say can dot fill rect, let's say at like 10, 10, we'll draw a square 50, 50. And we'll fill style that to be, let's do blue for now. Refresh. It appears to be working because we know that this has called this function because nothing else calls it, and we see our square here. And that means update is probably also being called. And we are getting this cleared. We can't really see that at the moment because it could just be drawing in the same place, but we can assume for now that it is working. Okay, that is the basics of setting up our graphics stuff. Now, what we need to do is set up sort of our character sprite, right? So I'm going to make another canvas just for visual means at the moment. And I'm going to call it temp can. And we don't need it to be this big. We need it to be, we're going to make our player 50. Let's try something smaller. Let's try like 32, because 32 is a pretty common pixel size for characters. Okay. Well, it will probably work like that. I want to give us enough of a broad view that we can see enemies coming from off screen. So if we made this 32 by 32, then that gives us another canvas right here that's this big, right? So we are going to need to make this canvas a little bit bigger because it's going to deal with rotations, but we will get to that in a minute. So we're going to say let temp can equal document get element by ID. We're going to call it temp can, and then let t can be temp can get context to D. Okay, so now we have access to that. Let's try the same thing, but on our temporary canvas. So we're going to say tcan and tcan do the same thing, but we'll do it at 0, 0 instead. And that should fill this entire canvas with blue, and it does. Okay, so we can get rid of this for now on our main canvas. So we're just working in this spare canvas. Let's make this spare canvas a bit bigger. Let's say it's let's say it's like 60 by 60, something like that. And then before we draw our player, we want to do some translations. So let's say t can translate. We're going to say temp can offset width, temp can offset height, and we're dividing both of those by 2. So we're translating to be at the center of this canvas. And then we said we wanted it to be 32. So half of 32 is 16. So we're going to say minus 16 and minus 16. And that should move it to be in the center, and it appears that it does. However, we keep translating it and drawing it because we have it in this loop here. And we don't want to do that. So let's say tcan.save. And then after we draw it, we want tcan restore. Let's see. Okay, that appears to have fixed our issue there. So we're saving it before we do the translate. We're going to do the translate. We're going to draw our character, and then we're going to restore it so that the origin is back in the corner again. So the next time we go through the loop, we can do the translate and all that stuff again. Now, another thing we could do is instead of saving and restoring, a better way to do this would to just say translate it, but translate it once. And we'll do that right after we make our reference to the canvas. So now it should translate once, and then it's just drawing it on the translated canvas. And that's a lot better performance-wise. Okay, well, we have a square, we said we wanted a circle character. So let's say draw circle JavaScript. And we are going to use the arc function. And let's make a couple of our players base properties here. So let player equal an object. What we're gonna need is a radius for the player's size. We're gonna say the radius is 16 because that's half of 32, right? And then we also want an angle that the player's at, which is going to be 0 to begin with. So we need to, instead of fill recting, we need to say we need to begin a path on tcan, begin path. We're going to say the center x and center y, well, that's 0, 0. Sorry, tcan.arc. So the center x, center y, the radius is player.radius, right? And then this says if we're drawing a circle, we need 2 times math.pi, because 2 times math.pi is the full radius of a circle. So we're drawing a circle we're drawing a circle using an arc. And then it says to end it in false. And then we need to fill it. So tcan.fill. And let's see what that does. That has drawn our circle that we're looking for, which is fantastic. Now, we don't just want a circle, because if we rotate a circle, we're not going to notice that it's rotating. So after we do this, how about we make like a quote-unquote gun or something, right? Let's just say tcan fill style equals, we'll say brown for now, tcan fill rect, and then we just want from like maybe like -5. No, let's do -2. 0 -2 to, we want it to be a bit longer than 16. We'll do like 18 and 4. I've done this right. Yeah, we get a little line that kind of pops out a little bit. I don't really like the brown look. Let's try red, and let's make it a little bit longer. Okay, we're getting there. Let's try like a purple. And let's make it a little bit thicker. We're going to say 4, and I think it's 8 it would need to be. Okay, that's maybe a little too thick. Let's down it to 3 and 6. Okay, that's decent. Let's maybe make it a little bit longer again. Let's try like 24. Okay. And I still want this to be like a brighter color, is sort of what I wanted. But I also want it to be visible. What if we kind of swap these around? Let's do black for that, and we'll do, let's try brown for the circle. Okay, that sort of looks like an enemy. If I do blue, I'm afraid of the 2 dark colors kind of clashing. Let's try doing an RGB value. We'll say no red, no green. We want blue 255. And then let's add a bit of the other colors to try and brighten it up a bit. That's not too bad. Okay. I think we'll go with this for now. So we have this, and we need to be able to rotate it. So what if I say the angle is... No, that's not what we want. I think we're gonna have to do the rotation with a save and restore. We also need to clear on this temporary canvas. So tcan clear rect 0, 0. But if this is after the translate, we're gonna need negative temp can, oh my gosh, temp can dot offset width divided by 2 minus temp can offset height divided by 2, and then we'll break it to the next lines. Temp can offset width divided by 2, or do we need the full? I think we need the full. Temp can offset height. So because we've gone into half of the canvas up here, we need to kind of go back from our translate and then clear. And we might just move this back down because we're going to need to restore anyway. So yeah, I think we'll do that just for simplicity's sake. Let's just clear the entire screen. We will translate after we do that. We can keep the fill style outside of this. And then we wanted to tcan save before we translate. And after we draw all this, we want to tcan restore. Okay. I believe this is working as we intended. So this is the gun. And this is the player. Maybe we will put this in with the translate and stuff. Probably before the path. We'll say this is the player. Okay. So we have our temporary canvas that we're translating, we're drawing this stuff. Well, then we actually want this to be 0, because we always want to draw a circle, right? What did I do? Oh. That is the radius. Okay. Never mind. I'm overthinking this. Okay. So we're drawing the circle. And then we're drawing the gun. And we're drawing it to the right, because that would be angle of 0, right? Now, before we do that, what if we tcan rotate by player dot angle? What if we did that? Then angle is 0 right now. What if I said like 90? Okay, well that doesn't look like 90 degrees to me, right? That's because this is 90 radians, not degrees. So we need to convert this from degrees to radians for the computer to understand, because computers measure angles in radians. So we said math.pi divided by 180 is 1 degree, right? Well, if we have 1 degree times 90, that's 90 degrees, right? So let's try this out. Okay, it's down, not up. Why is that? That's because, like I discussed earlier as well, I'll see if I can pull it up. In this bottom bit here, I said y is positive down in graphics, right? So if y is positive down, then a positive angle is also going to go down. So instead of going around the circle this way, counterclockwise, we're going around the circle this way clockwise when we're on a computer screen. So something kind of tricky that you might need to keep in mind, and we may need to tweak some things if we run into issues with that. So now we know that this angle thing is working. Let's try and draw our temporary canvas onto the main canvas. I also want to just do 45 degrees here just to test this. And then let's make our temporary canvas about as small as we can get to try and kind of hug that. So let's try like 50 by 50. Okay, let's try maybe 45 by 45. We want to make this canvas as small as we possibly can without causing issues in how the image is drawn. So in update, what if I just say player.angle plus plus? Yeah, sure. Oh, that's really fast. Let's say plus equals 0.05. Okay. So it does kind of clip with the edge of our canvas a little bit here and there. So we do need to make it a bit larger. Let's maybe just do 50. I'm pretty sure 50 will work. Okay. 50 is almost perfect because we're not hitting the edge at all and we're able to draw the whole thing, right? So let's cut this out. Go back to 0 degrees. And we can just remove this for now as well, because 0 times anything is going to be 0. So we drew the player in this temporary canvas. It's facing to the right. Now we need to render this canvas onto our main canvas. So that's going to be draw image. We need it to be our temporary canvas. And if we said 0, 0, it would draw it in the top left. But just to make sure, I want to try angle plus plus again. But plus equals. Pretty sure this shows me what I need to know already, but okay. I was making sure that it was getting cleared before it was drawn, so it would still be transparent and not drawing what was behind it. So now that we have that, let's center the player on our main canvas. So to do that, we will say canvas offset width divided by 2, canvas offset height divided by 2, and then it would be half of our character width, which is actually going to be our canvas width and height. So we need to say 50 divided by 2 and 50 divided by 2. And then we're going to need to subtract. No, sorry. Width and height are going to stay full. We need to subtract 50 divided by 2 from here and subtract 50 divided by 2 from here. Because we are going to the center of the canvas, which is here, but then we need to go left half the width of this, which is 50 divided by 2, so we'd go here. And then we also need to go half of the height, which would be here, and then we're drawing the full width and height, which should put it right here. So we check that out. It appears to be in the center of the screen. We did a good job. So now we need to find our preferred way to hide this canvas because we don't need it anymore. So we can either just say this style display none. I think I showed that this doesn't work. Yeah, it does not. And I think that's because offset width and offset height are not set. So in here, instead of doing this, what if we just raw put in 50 and 50? And this is 50. And this is 50. And then we try it. It appears to still be working. Let's try style equals display none. Okay, now it's working. So as long as you have the raw things here, because it won't have a width or height if we display it none, then you can just hide the canvas on your page. Like you see the canvas is still here, it's just not being displayed. So if you do the raw values, you'll be good that way. But I want to do it in memory instead of on the page. So instead of making this a reference, we're going to say equals document create element, and we're going to call it a canvas element. And I think that is having issues because I need to set the width and height. Temp can width is 50. Temp can height is 50. Okay, seems to be working. So let's get rid of this canvas because we now have an in-memory canvas that does the same thing. And let's change this to be player can, and this will be pcan, or sorry, player canvas. We're setting the width and height here. So player can, this will be pcan. And then we're just going to replace tcan with pcan everywhere it comes up. because it's not a temporary canvas anymore. It is the player's canvas. Temp can is not defined. Where might that be? Here. But this would be player can. Temp can is not defined still because this is player can. Okay. We appear to have fixed all of the references. Oh. Ugh. I feel like I'm wearing my brain out for some reason. Okay. Let's just try spinning the character again now that we have an in-memory thing. So player.angle, angel, plus equals 0.05. I want to make sure it is clearing properly, and it looks like it is. So we are completely done with that player canvas now. So we have a player, the player is in the center of our screen, and we can rotate the player depending on what angle it has, right? So now we need to make some things for our mouse. I think we'll do it here. So let's say document. No. We're going to say canvas because we want to know our mouse position in relation to the canvas. And we might need to change this, but we're going to say on mouse move is going to be a function. And we want to console log. There's going to be an E here. Let's just log E. Let's refresh. You see nothing happens until we move on to the canvas, but when we move on the canvas, now we're getting some output. So I'm going to go as close to the top left as I can. And then I'm going to open this bottom one. We see there's an offset Y. I don't see an offset X. We have the screen values. We don't want the screen values. We have the page values. I don't think we want those either. Let's make this bigger just to make sure that we're looking at the right things. So if I go to the bottom right, then we look in here. So client X is really big, client Y is kind of small. The layer stuff appears to be the same as the client. And then we have offset X and offset Y. Now that looks pretty close to the edge of our canvas here. So I think we'll use these offset values. Yeah. So these offset values are what we're going to want to use. Let's go back to this size. And we're going to say, let's make a mouse object. Just to keep track of some stuff, we're going to say X is 0, Y is 0. Just so we have some default values. Let's say mouse.x is e.offsetx. And mouse.y is e.offsety. Okay. Now, if I move my mouse over here, we don't see anything. But if I look at mouse's values, it's very close to the 900 by 600 we defined. So we know that that is probably pretty close. Let's go up here to where we're basically touching the top left. And then we'll check it again. We see X is 1, Y is 0. So it appears to only be doing the coordinates inside of our canvas, which is what we want. We don't want to include the page or the whole screen itself. We just want the coordinates inside of the canvas. So that is giving us what we're looking for. Now, here's where kind of the tricky parts come in. So we have coordinates, but our coordinates are starting at this origin, right? And we want the angle from here to wherever our mouse is. Well, in order to do that, this needs to be our origin, right? So in order to make this our origin, what if we shift everything minus half the canvas so that it's over here? And then we do our calculations from there. Because that will mean the player is at 0, 0, and then our mouse would be somewhere like up here in relation to this 0, 0 point, right? So we're gonna do that. And that's a bit of game logic that you'll probably have to get used to, is shifting your origin like that. Because we don't want to actually change how the canvas draws, we just want to change how our math calculates. So in order to get an angle between the player and the mouse, we said we need to take for now, let's make a little function here that's like get player angle, okay? And then we'll just call get player angle. And let's console.log that. So we should constantly be getting whatever this function returns. And I would like to stop that for now in the console, in the browser, because that's going to annoy me. Okay. So, math. So we know we have player X and player Y, right? Well, player X and player Y are the canvas offset width divided by 2 and canvas offset height divided by 2. Okay. And we're kind of pretending that the origin of the player is in the middle, which is why we can draw it like this. So then instead of saying draw it here, we can say player dot x and player dot y, because those are the same things. And then we're subtracting half the canvas width and half the canvas height here, right? So now we have our origin. We need to say, like origin x equals player dot x minus canvas offset width divided by 2, and origin y is player dot x or y minus canvas offset height divided by 2. So the new origin would be here for our player, And then we need to do a similar conversion on our mouse. So let mx equal mouse dot x minus canvas offset width divided by 2. Let my is mouse y minus canvas dot offset height divided by 2. Because we're doing the same translation to both the player and the location the mouse is at, right? I'm going to say px and py. It says the player's x, the player's y, the mouse x, and the mouse y. And these are our translated values. So now that we're at the origin, we can do our math functions. So we wanted to get the base here, right? So let base equal, and we want the player's x position, so px, and we want to subtract that from the mouse's x position, right? So mx. That will give us the base of our triangle. Then we want the opposite. So let the opposite, I guess I should call this the adjacent. Oh my gosh, keyboarding is hard. Equal. And this is going to be the difference in our height between the player and the mouse. So we need the mouse's y minus the player's y is going to give us our opposite here, right? And we might need to flip the y because y goes up in our case, right? So we will have to think about that later, I think. But then we need to know the angle that these two make. And we said in our maths here that in order to get this angle, we wanted to do the inverse tangent of the opposite over the adjacent in order to get the angle, right? So let's figure out how to do the opposite. I believe co is another way to say the inverse. So I'm just going to Google. No, hold on. Inverse tan JavaScript. It's called atan. So we're going to say we need the math atan of, and we said it was the opposite over the adjacent, right? So the opposite over the adjacent. And this is going to be our angle that we wanted. However, depending on how this works, we might have to do a radian to degree translation for us. But we're going to have to play with it to figure out what we want to do with that. So let's just say player angle equals angle. And if we refresh, we're getting undefined because we're not returning this. So let's return angle. here we're saying player angle equals this thing. And then we could just log player angle. Okay. So we notice some strange things going on. Basically, we're not getting the correct angle in degrees. And we are getting a flip across the y-axis when we do that. So in order to fix this, let's try a couple different things. Let's see if we can just change this to be 180 divided by math.pi. Let's see if that fixes the angle thing. No, let's try the other way. Math divided by 180. Okay. It's still freaking out. Let's try to break this apart and see what we're doing. First, I want to look up how we're rotating. So we're rotating by an angle. Is that angle degrees? The answer was no, right? So if I want to rotate by degrees, then whatever we set the player's angle to, we need to multiply that by math.pi divided by 180 to make it degrees, right? So let's play around with some things. We're getting a lot of like zeros. Let's try flipping the my. That has not fixed anything. I probably should have done a test run of this before doing it live. Because now you get to see me struggle with this a little bit. So how does A10? Does A10 take in degrees or angle in radians? Okay. That's what I expected. So this, we are getting the angle in radians. Down here, we're rotating it in radians. Because if this were here, it would need to be negative. It doesn't appear to want to do that. Left and right, it wiggles a little bit, so we know something's going on. And I do know at one point we're gonna have to do a flip on this because it's negative. So, oh, what's this here? Okay, well, we had an equal sign hiding in with our stuff, which is not great. We know as we go further from the player, it doesn't seem to make a difference. But as we go around the player, it seems to get greater and lesser until this axis change, which is what we wanted. So, player X and player Y. If we subtract this, it should be basically 0. Mouse X, subtract this. Mouse Y, subtract this. Give us negative numbers. Then we need the A10 of the opposite over the adjacent. It seems to wiggle back and forth, which is what we want. We shouldn't be multiplying it by anything if we plan on using radians. Oh, there we go. Okay, so this is what we were looking for. Now it's looking at the mouse. So we know that our math is right. But you'll notice when we jump the y-axis, it flips it, right? And then it goes like opposite of our mouse, and we don't want that. That's because at a certain point where it flips, we get to a point where our adjacent is 0, and you can't divide by 0, right? It's like just an impossible thing you can do in math. You can't divide by 0, right? So what we need to do to compensate for this is we need to say if we need to have like an if statement in here. And we need to say if we'll say mouse, sorry, let's say mx is greater than px. So if the mouse's x is greater than the player's x, then we don't need to do anything, right? So if it's less than this, then we need to add 180 degrees, which is pi. So we need to say angle plus equals math.pi. Okay, so now no matter where our mouse is on the canvas, our player is looking at the mouse. And then if it is 0, on the very like small off chance that it is, right? We should have an exception for that. You could just ignore this exception because it's probably never going to trigger. But we should have some kind of listener for it. So if mx minus px, that's if we're like right here, then what do we want to do? Well, we could just say something like if adjacent is 0, then what if we just say like adjacent is like 0.01 or something? So it'll never actually be 0 before it goes into this calculation. It'll just be really close to 0. I don't really like that fix though. So let's think about this for a second. Do I want to go with that fix, or do we want to do something different? Hmm. Hmm. Either gonna be... Okay, I found a different solution that I'm thinking of. So if the adjacent is 0, which is basically your mouse and your player are the same x value, then what we can do is we can check if the mouse is above or below the player. And then we can just tell it, look, either 90 degrees this way or 90 degrees that way, right? And that will be a perfect solution. So we need to say if the adjacent is 0, then if my is greater than py, then our angle is going to be return math.pi divided by 2. Else, we're going to return negative math.pi divided by 2. And I believe that will fix our 0 problem. Unfortunately, we have no way of really testing it, but I believe that will work. If we run into a strange, like, flicking thing happening later on in the game, then we'll know that logic is wrong, right? But anyway, right now we have the player that looks at the mouse, which is exactly what we wanted. And we will just have that update the player's angle every time we run this function. Trying to think of a way that we could make this a more generic function so it's not just the player. Like, I could just say get angle, or like get theta or something of like x1, y1, x2, y2, and then, you know, px is x1, and then py would be x1 or y1. This would be x2, and this would be y2. And then instead of there being no arguments, we could say player.x, player.y, and then mouse.x and mouse.y. I mistyped that. And that should still do the same thing, but we said get angle instead of that. Okay, we're still getting the same result, and we don't need to log this anymore. So now we have a more generic function that we can maybe use for something else to get an angle, and we'll be using that for when we fire bullets. So I don't really like calling it get angle. Let's call it get theta, because theta is a cool word that basically means an unknown angle. And then we're gonna hide this function away until we need it later. So then we probably want to draw the temporary canvas stuff before we draw the main canvas stuff. So let's maybe even make like a temp or a pecan render, and then we'll make the actual render. So pecan render is going to be a function, and we're just going to take this stuff out of here and put it in here, because the only thing that interacts with our player canvas is the player, and I don't want it in our broad render function anymore. So we're just going to say basically render the player, render player, and then this will clear the canvas, and canvas, and then this will be draw player in the center, right? And I can probably shorten this now to be more like this, so it's only 2 lines for you guys. Okay. So that's good. We extracted some code out, so we don't need to look at it anymore. We have our update and render functions here. They're both still pretty clean. Cool, cool, cool. My coffee's not waking me up today. All right. Let's shoot some bullets. So, we need to know what a bullet is, right? Let's do a similar thing to Cube Wars. And we'll just make a constructor here. It's gonna need a vel x and a vel y, which you can write x vel, y vel, however you want to write it. I'll probably swap it up back and forth, depending on how I feel on the day. This dot vel x equals vel x. This dot vel y equals vel y. Then we're just gonna say this dot width is 5. This dot height is 5. 5 by 5 is a pretty decent size. And then we'll need to set the velocities later. So now we need a way to make bullets. I want to do it on mouse down. So let's say canvas on mouse down is a function. And we're gonna say when we mouse down on it, that player.shooting is true. So let's add a shooting variable here that's false by default. And then on mouse up, we're gonna change this to false. So while our mouse is down, we should be shooting, and when we release our mouse, we should stop shooting, right? And then in our update loop, we're gonna update the player's angle, and then we need to create a bullet. So for now, let's make a process bullets function similar to how we did before. I'll put it here. Temporarily. I think we need to unindent that for consistency. Okay, so process bullets. The first thing we need to do is we need to make a bullet, right? But to make a bullet, we need a velocity for both of these. And we also need a way to manage our bullets. So let's make a bullets array. It's going to manage all the bullets we're shooting, same as cube wars. And we will say let bullet equal new bullet. We need to capitalize this because it's kind of like a class. And for now, we're just going to say 0, 0. And then we need to say bullets push bullet. And then bullets for each bullet. Let's maybe even call this new bullet so that there's no confusion here. For each bullet, we need to say that the bullet x plus equals bullet vel x and bullet y plus equals bullet vel y, right? So we're gonna make a bullet, but we're only gonna make a bullet if player dot is shooting, and I think we need to change this to is shooting. Is shooting. Is shooting. Try and stay with the conventions of naming. So if the player is shooting, then we want to make a new bullet. But no matter what, we want our bullets' positions to be updated by their velocities, right? Okay, that's cool. So now we can make bullets. We are gonna have to render the bullets. So let's say bullets for each. We're gonna say bullet arrow function. Fill rect at bullet x, bullet y, bullet width, and bullet height. And before we do that, let's say fill style is going to be red. We might change that. Let's change it to green for now. Okay. Unexpected token semicolon is shooting. Right there. Okay. So we click down, we would be shooting, but we're not doing anything. Let's say console log, there is shooting. Make sure that that's working properly. It appears that it is. So that is not the issue. What might be our problem? The problem is our bullet doesn't have an X or Y. So this dot X equals, and then we're gonna instantiate them in the center of the player. It'll make our angles and stuff easier to calculate. So we will just say this dot X is canvas get offset width divided by 2. And we will say this dot Y is canvas get offset height divided by 2. Okay. Now we are still not getting bullets. Let's try a console log on bullets. Make sure they're getting added. They are indeed getting added. So what might be our issue here? X and Y are not a number. Did I say offset? It's not get offset. It's just offset. Off has 3 F's in it, obviously. Okay, now it's working. Okay. But because our width and height are 5, we actually need to subtract a bit. Let's lower this to 4, just so we can do a half. And we're going to minus 2, which is half of our bullet size. So now it's truly in the center of our character that it's spawning the bullet. And I know you probably can't see that. Let's maybe up it to 6. And we'll lower these to, or up them to 3s. Okay. We're going to change the color so it's easier for you guys to see at the moment as well. Okay, so now we have red dot that spawns in the middle, right? And that's the bullets we're shooting. But they're not going anywhere because their velocity is 0, 0. And we put that right here. We said they're not going anywhere, right? So if I said they were 5, then when we shot, they'd be going off to the right because their X velocity is 5, right? Okay, now here comes a more complicated part. Because let's say we want our bullet speed. So let's say this dot speed be 7, right? But we don't want it to be 7 to the right or 7 up. We want it to be 7 in like a hypotenuse sort of way. But as far as velocities, we only have X and Y. We don't have a diagonal axis to do calculations with velocity, right? So what we need to do is we need to get the angle that the player is facing. And we already did the math to get that when we do the player angle here. So after we do that, we need to figure out what our bullet X and Y velocity would be. And so we will do that as part of process bullets. So basically, we need this process bullets to come after we set the player's angle. And then we need to do the math I was talking about in this section. Is we'll know the angle, but we need to decide the hypotenuse and then find the X and Y from that. And that's going to be our x velocity and y velocity. And this is our overall speed we want it to go. So we decided we were going to use these two functions to do that. I'm just going to pull it off so that I can use it as a reference. Okay. And this is why it's really important to do a lot of your game maths before you start working on the game. So you have like a visual representation, or you have like your work written out so that you know what you're referencing. So we need to say that we need to say for vel x, so let vel x equal, we said for the x velocity we were using cosine. We're saying it's the math dot cosine of whatever the player's angle is, and that equals the x we're looking for over the speed, which is going to be bullet dot speed, right? And I want this to be a more global thing. Let's just make it its own global thing for now. We might fix it later. We're going to say bullet speed is 7. Just so it's not in this class and we don't have to make the class before we can access it. So we're going to say bullet speed. But then we took this and we rearranged it so that xvel was on the outside. And how we did that was we divided the adjacent, or hold on. No. We multiplied the cosine of our angle by our bullet speed, because that leaves us with this and bullet speed times that, right? So then we would just have xvel or vel x, which is what we're trying to get. So it's whatever speed or the hypotenuse times the cosine of the player's current angle, and that will give us the x that we need. Now we also need the y. So we're going to say let vel y, and then we had a different set of maths we wanted to do for this. We said it's math sine of the angle again, so player angle, and that equaled the vel y over our bullet speed, right? And then again, we just said, well, instead of dividing here, why don't we just multiply the other side by that? And that will leave vel y alone, which is what we're looking for. So pretty much the same algorithm, but we're using cosine for x and sine for y, right? And again, we're just referencing this, saying, okay, we have the player angle here. We have the bullet speed here. And then we're just solving for x here and y here. So Basically, you're just going to need to play around with it and learn your trig. But once you learn it, you'll be able to make these kinds of games so that you're not bound to just X and Y. You can also do velocities and things, which opens a big gateway for you into doing other things with games. So now that we have the val X and val Y, we can just say, well, val X, val Y. So now when we make a new bullet, it's going to look at where our mouse is in relation to our player, and it's going to shoot towards the mouse at this velocity, like with this X and Y, which in total will be our bullet speed in that direction. And the reason we have to do it this way, instead of just saying like, well, why don't we just say vel X is the bullet speed and vel Y is the bullet speed, is because that makes it travel more than 7 pixels per second, essentially, in like the actual world space, which makes it so if you're shooting a diagonal bullet, the diagonal bullet would go faster than if you shot a horizontal bullet, and we don't want that. So this actually makes the bullet travel in a realistic speed. So let's try it out. Refresh, shoot some bullets. It appears to be working. We're shooting bullets towards the mouse. And that's great. That's exactly what we were going for, right? And then if we wanted to, we could do kind of a translate to like make it more towards the end of the barrel. What I think I'll do is I think I'll process the update for it. We'll say 2 or 3 times before we actually make the bullet. So essentially what this is doing is it's saying, well, we would go this speed, and I need to do this after we make the new bullet. Sorry. And it would be new bullet instead of bullet. Okay. So instead of doing some more complicated, like translate mathematics to try and move the bullet to the end of the barrel, what I'm doing instead is I'm saying before we add the bullet to the bullets array to be drawn and like played around with in our update, I'm gonna just update the location a couple of times in relation to its velocity that we found. So I'm essentially just spitting the bullet out further from where it would originally start. So if we try this and refresh, now it kind of looks like it's coming out of the barrel. Let's try even one more of these updates. Okay, now it looks like it's coming out of the barrel, right? And it's a lot easier to just basically update the location behind the scenes a couple of times and keep the same logic than it is to try and do like a translate to change where the bullet would actually spawn, right? So now this is great, where we've got a rotating player and the player shoots from the barrel of its like gun or whatever, and we can work with that. And all the bullets are moving at a constant rate in diagonals instead of just left and right, which is fantastic. So our bullets are more or less done. We do want to make kind of a memory limiter on it. So when we are shooting, if we add a new bullet, then we want to say if bullets.length is greater than think we said 100 was a decent size with cube wars. Then we will just bullets.shift, which should delete the oldest bullet we've made. So now we should never have more than 100 bullets currently on the map. And don't know exactly how I want to test that, but it appears to be working properly. I could just say something like console log bullets length. Then when we refresh and open console, we're gonna make bullets until we get to 100, and then it stops at 100. So we know we have maximum 100 bullets on screen, or at least in memory. So we know that's working, which is fantastic. So our bullets are made. Now we need some enemies, right? Enemies are gonna have to deal with velocity as well. And they will need to find, I believe, both the angle between them and the player, and they will need the speed logic of the bullets, right? So how do we want to do this? We can do this one of two ways I can think of. One of them sounds more fun to me, but I didn't really explain it. Let's maybe do some more math. If you weren't overloaded already. So this is pretty simple though. If we have a circle, right? Why is this like a weird size? Okay. This should be good. So we have a circle, right? And we are going to find a point on the edge of the circle. This is actually really simple. You have your radius here, and then you have the center of the circle here. This is the radius. And then let's say you know the angle, okay? So you know the angle. We're still going to write theta though. I want to rotate this R to be angle. So it will be like this, right? But I want to find the point here. I want to find the point of it. If this is 0, 0, and I know the radius and the angle, I want to know what the point here is. So I believe this is R cosine of theta. And this is R sine of theta. So basically, you're rotating R from 0 degrees to be whatever degrees this is, and then you're multiplying it by R to get it out there, and then that is the point, because you're starting at 0, 0. If you had to translate or something, there'd probably be like an addition of like the origin Y, origin X, or something on the end here. But because we're at 0, 0, we don't need to worry about that. But yeah, that's how you would get the point on the end of a circle. And we're going to use that to spawn enemies and kind of have them get closer to you as well. I think in kind of a fun way. So we're gonna move this off screen. Sorry, screenshot it or something if you want to. We're gonna move this off screen, so only I can see it, just to remember what I'm doing. And we are going to do some work with that. So let's make an enemy class, or let's make an enemy function. We'll kind of manage them similar to how we're managing bullets. So we're gonna make an enemy, and it's gonna take an X, a Y, and I think that's all we'll need, really. Let's say this dot X equals X. This dot Y equals Y. And then we'll say this dot... we need an angle. Maybe. Hmm. Yes, I believe we'll give them an angle. We'll start it at 0. And then we will say this dot, and we'll say, call it distance. And we'll set it by default to be like 10. Okay. So I'm trying to set up something kind of cool. Not exactly sure how I want to approach it, but essentially, I want to spawn an enemy at distance like 10 from the player, okay? And then I want to manage that distance for the enemy so it gradually gets closer to the player until its distance is 0, at what point it will touch the player and you will die, right? Unless you kill it first. Then angle is going to be the angle from 0, right? And I want to be able to update that angle so that it kind of rotates around the player as it gets closer to the player and eventually touches the player. Because that way it'll be harder to hit if you have to go around in a circle, and you'll have to like counter orbit the thing in order to get all of the oncoming enemies. I think that'd be pretty cool. So instead of X and Y, we might just need angle and distance. And then we'll give it a radius of, let's see, what's our radius? 16? Let's give them a radius of like 32. Okay. And we're probably gonna need to up this distance, but we'll play with it. So we're getting into some kind of gray area that I haven't exactly taught you, but I've taught you the math that you need to know to figure it out. And we're just gonna play with this a bit. For one, I don't need to log this anymore. I think maybe I just haven't refreshed the page. Yeah, I just hadn't refreshed the page. Okay. So we're gonna need sort of a spawn clock. But for now, let's just spawn enemies. We'll do it here. Spawn enemies. Or maybe even process enemies. Because we will need to move them as well. Okay. So for now, we're just going to spit out an enemy every frame, which is going to get crazy. And we need an enemies array. Enemies. Let's make an array. So we're going to say we're going to make a new enemy. And for the moment, we're not going to pass anything to it. We'll find out if we need something else. We make a new enemy, and then we're going to say enemies.push this new enemy. So what if I say let new enemy equal that, and new enemy is being pushed into here. Then let's render the enemy. For now, let's do a square. Well, we already have the radius. We might as well do the circle. So bullets, I want at the top level. Let's do enemies above the player. So enemies for each enemy. Your arrow function. We need to say, we need to render it. So, I believe, let's just Google draw circle JavaScript again. So we have a start angle, which would be 0. And angle radius. Okay, so we're going to can begin path. We're going to can arc enemy dot x. Oops, enemy dot y. So we will need those values. And then the radius, enemy dot radius. Start angle was 0 and the end angle was 2 times math dot pi, because we wanted to make a circle. And then can dot fill, and we need to say fill style. We're gonna make red, so we are gonna have to change the bullet color. Let's just try green. We don't really need to pay attention to the bullets anymore. So van is not what we're looking for. Okay. So now we need enemies to have a location too. So enemy this dot x equals, we'll say 50 for now. This dot y is 50, and it should just be a circle. Okay, that's exactly what we want. So we will need and X and Y to begin with, maybe. I don't think so. I don't think so. Let's think about this. Let me just refresh this. My computer's starting to stress itself out. So we know the distance we want to spawn the enemy. We don't know the angle. So what if we did kind of a randomized angle? So new enemy dot angle is going to be equal to we need anything between 0 and 2 pi. We're going to say generate random number JavaScript between 0 and f.pi times 2. Let's see what Google says. Generate a random floating point number in JavaScript between 0 and pi, exclusive. We need to multiply the result of MetaRandom by pi. Let's say, well, I guess 0 is still that, so yeah. So we need to say this is math.random times math.pi times 2. And this will give us in radians any angle between 0 degrees and 360 degrees, which is what we're looking for. So that's the angle the enemy's going to be from the center of the screen. Now we need to get the position of the enemy at this angle, and give it an X and Y. So we said on our maths that new enemy dot x would be equal to the radius, which is going to be our distance. So new enemy dot distance times, and we said it was math dot cosine of the angle, right? And then for the y, same thing, but it was going to be the sine of the angle, right? Now, what we're going to run into with this is we only see like one enemy here. For now, I'm also going to put this out here. I only want it to happen once. I don't want it to keep adding enemies. So we have this enemy. Distance. Let's see, enemies. Let's take a look at this enemy, see what it has. So the X and Y are not too crazy. The distance is 10. But this sine and cosine may be like a fraction. Hmm. Let's kind of break this down a bit. So console log new enemy dot angle. We're gonna say angle. Then similarly, we're gonna say x and y, x, y. But I want to look at the cosine of the angle. So cosine of the angle is going to be this. I already know we need to translate it, if that's what you're wondering about, but we're not there yet. So let's get another log. We said this was sine of A. Is here. Okay, so now when we refresh, it should give me all these values. So we see that this is a fraction, which, if it's a fraction, it's going to make our distance smaller. So what do we want to do about that? We could divide instead of multiply, but I don't think that's the answer. We want the distance to be... I suppose let's center it as well. So it'll be whatever this is plus the canvas offset width divided by 2, and it will be this plus canvas dot offset height, and we can break that kind of like this, I think. Okay. It appears to be spawning around here because I need to divide this by 2. Okay, so now we're spawning randomly around the player. We just need to adjust the distance from the player. And that is what is kind of the issue right now. So I could say the distance divide that. Maybe we need to make the distance larger as well, because it should be like at least like 400 pixels away from us or something, right? Maybe not 400. Let's try like 200. Oh my gosh. Okay, we did see it for a second. Let's go back to multiply. We may have discovered the issue. Okay. Basically, the distance wasn't large enough for us to really see it work as intended. But now it's spawning randomly around us at a distance of 100 pixels. So let's increase this to like 400. Okay. I do want it to be like kind of off screen. And I think I want to square the canvas as well. Let's do 900 by 900. No, 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 no. Let's do 600 by 600. Okay. I feel like that's not enough room. Maybe we do 900 by 900. And then I'll just drag this down a bit. Okay. That's kind of what I was going for. So now we have the same vision this way as we have this way, and then our diagonals are going to be a bit easier to see than our verticals, but that's okay. So we know half of 900 is 450. So if we say 450, it can spawn right on the edge here. I want it to be able to spawn, or I want it to spawn off the edge, right? So let's maybe say like 600. Oh my gosh, I cannot type. Okay. So now they should be spawning off of the screen. Occasionally they're spawning on the screen though. Let's maybe give it a little bit of a nudge. We'll even say 700. Just to make sure it's spawning off of the screen. Okay. Now, we don't need to log all this stuff anymore. We got our debugging finished. So we can create a random enemy. And then we add it to this enemy array. We want to go back to processing the enemies all the time. So we're going to keep making new enemies. And then, after we make new enemies, we're going to say enemies for each enemy. We need to update their positions similarly to how we're updating the bullets every frame. So we want them to get closer to the player, right? Which means that the distance needs to be lower. And then we also need to update their X and Y according to their new distance. So what if we do this again, but we say enemy.distance minus equals, we'll say like 4. It'll be kind of slow to begin with, but we'll see how that goes. And then all of these new enemies just need to be changed to the enemy we're currently working on. And I believe that will work. Let's test it out. Oh, shit. Okay. So, something interesting is when it gets past us, it continues going, which is fine because we should end the game when that happens. But we are indeed getting swarmed by a bunch of enemies from all angles coming from off the screen, and this is kind of what I was intending. But I also want to give them a rotation direction. And this is gonna cause a lot of lag because we're creating so many of them. So I'm gonna comment that out for now. So let's work on limiting how many spawn first. Let's say enemy let enemy spawn timer equals 0. Okay. And then we will say every time we go to process an enemy, we're going to say if enemy spawn timer is equal to 60, then we will spawn an enemy. And then we're gonna say every update on if it's greater than or equal to 60, then we'll spawn an enemy, and then we'll say enemy spawn timer equals 0, and then yeah, I mean else is an easy way to do it. Else enemy spawn timer plus plus. So how this is gonna work is the timer starts at 0, and we're running this every frame. So we're doing 60 frames per second, right? Because we're doing 60 loops per second. So every time we loop through, it's going to process enemies, and it's going to say, is it greater than or equal to 60? And it's going to say no. So it's going to increment the timer. So every frame, we're increasing this timer. And then after 60 times we've incremented it, then we're going to spawn an enemy. And what that means is, like, if you break the math out, it means every second we're going to spawn an enemy. And then when we spawn an enemy, we reset the timer so that it won't spawn another enemy for another second. So let's check that out. Okay, that's 1, that's 2, that's 3, that's 4, that's 5. It appears to be working as intended. They're not disappearing, they just keep going, which is fine, because eventually their distance becomes negative, which is why they go the other direction. But yeah, this is a pretty cool, like, asteroids kind of setup we have here. Let's work on what do we want to work on? I guess collisions would be nice. Trying to decide if enemies should have health or not. Like, do we just want to hit it with 1 bullet, or do we want to hit it with a couple bullets? Let's give them like 5 health, and we'll see how that goes. Say this dot health. You know, I don't think we'll do that. I think we'll just say if an enemy touches a bullet, then the enemy dies. Which means we need this dot enabled, or like is enabled, is true. And this dot is enabled is true. Okay. So again, this is going to be like a toggle of whether the enemy or bullet is actually active. And I was going to do something else too. That was going to make this cooler. Let's do the other thing first, because we're still working on the enemy stuff. So I wanted to give it a direction to go. This dot angle adjust is 0 to begin with. What I want is whenever the enemy gets updated, which is here, I actually want to change the angle the enemy's at a little bit. So let's say enemy dot angle plus equals enemy dot angle just, and then we need to give it a basic adjustment. New enemy dot angle adjust equals, and I don't want it to adjust by a lot. Kind of want to do a random number between 0 and maybe like 10 or something. So let's Google that real quick, if Windows will cooperate. No. Let's open a new Firefox tab. I keep closing it. I really shouldn't be doing that. I guess we'll save this as like circle position or something. Okay, so JavaScript, random number between 0 and 10. Okay, I was pretty sure it was something like this. So it's math.floor, math.random times 11. And that will give us something between 1 and 10. But I actually want to divide that by... I want it to be less than 2 pi. So if I... play with some things here. 2 times math.pi. I want it something between this, like 0 and this, but I don't want it to be like a ton, you know? So if I said it's a random number like this, but then I divide that by let's play with some stuff. So if I did divide by 180, I believe that's kind of like a random number within pi, like a random degree, right? Let's just try that. It broke somewhere. Oh, shit. What's going on here? That's not what I wanted. The angle. That's crazy. It does appear to eventually hit the player, though, which is cool. Actually, no, this is what I wanted. I think it's just doing it really fast. What if I divide this by like 360? Okay. This is doing what I wanted. Okay. Okay. So essentially, if I want this to be positive or negative, so I'm gonna need another math floor, math random. We're just gonna call it temp. We're gonna multiply that by 2. And that should be between 1 and 0. And then we're gonna say if temp is 1, else we're gonna say this is this, or it's this. I think that will accomplish what I'm going for. Okay. Yes. But let's lower the enemy speed. Which was here. Let's lower it. I'm trying to get a visual way you guys can see what's happening. Okay, so this is orbiting me, but it's slowly getting closer until it touches me, right? So we're slowly adjusting the angle until it gets us, which is not exactly what I wanted. Let's lower the speed again. Let's do, let's try like 0.5, something like that. And let's also put this somewhere else. Say like, um, maybe this dot speed is 0.5. That's how close it's getting to us. So enemy dot speed. Okay. Trying to go for an effect that I think would be really cool. Oh, that dude's flying. Okay. So they're all gradually gravitating to me, but some of them are like flying around in circles. They go this way, they go that way. Like, eventually, though, all of these circles are gonna end up touching the player. And that's kind of what I'm going for. But I want the lower end of the speed. Well, I don't know. Honestly, this is fine. It kind of has like a floaty, kind of spacey feel to it, right? Had a little Jaws moment there. Like this is like almost 0 orbit, so it's running right at us. Whereas these have some higher orbits. We're gonna have to shoot them before they get close. Some of them might kind of sneak up on us. Some of them will go, um, really fast around. Other ones will go straight at us. I think this is fine. Um, Now we need collisions. So we need to say, I suppose we'll do bullets first. And for that, we need the this dot is alive and this dot is alive. Because we need to disable them. So for drawing bullets and enemies, we need to say if enemy is alive, then we will draw it. And if bullet is alive, then we will draw it. Okay. So by default, the bullets and enemies are alive. We need to say process collisions. And we can just throw this stuff down below render because we are done processing their movements. So we'll throw that here. And so now our update is kind of small again. Now we're gonna kind of mess it up again. Process collisions. And we need to say for each bullet, it needs to see if it can hit any enemies, like collide with it. So we need to say bullets dot for each bullet. We're gonna do an arrow function. And then we're gonna say enemies dot for each enemy arrow function. So this is a nested loop. We're saying for every bullet, we're gonna check its collision with every enemy, right? So we need to say if bullet dot x plus bullet dot width divided by 2. If the width divided by 2, that'd give us the center of the bullet. I think we'll just do collisions with the center of the bullet because the bullets are square. But they're small and like, you know, I basically just have a size on it so you can see it. It's not really meant to be visible. It's just supposed to be a point. So if that, we're gonna have to write a distance formula. Yeah. Okay, let's write a distance first. Function distance. And then we need an x1, an x2, a y1, and a y2. We're going to return math.square root of distance formula. It is x2 minus x1, and we need that squared. And in order to do a square, you're gonna say times 2. That's how you do a power. And then we need to add Let's do both these. Y2 minus y1, and that is squared. Boom. So that is the distance formula written in JavaScript. We're taking the square root of this squared and this squared. So now we need the distance. If the distance of the center of our bullet xy's, which would be our x bullet position, technically for this formula, and bullet dot y plus bullet dot height divided by 2, which would be our y position for our bullet in this instance. If that is the distance between that and enemy.x and enemy.y, if that is less than, well, our bullet quote-unquote radius is bullet dot width divided by 2, right? Plus, and then we need the enemy radius, and we should include equals because they would still be touching. Then there's a collision. So basically, in layman's terms, if the center of our bullet and the center of the enemy, if the distance between them is less than or equal to the radius of our bullet and the radius of the enemy, we're going to call a collision. And this radius of the bullet, it's kind of inaccurate within like a pixel, but because it's such a small amount, I'm not going to worry about it. This is a kind of an error with our logic between circle and circle collision, is we're not doing circle-circle collision, we're technically doing square-circle collision, which is kind of a different thing. But anyway, like I said, it's a close enough thing, and we're going to use a similar thing for the player and enemies. So that's why I wanted to write it like this, so we can just copy and paste it and be done that way. So if a bullet hits the enemy, then the bullet dot is alive is false, and the enemy dot is alive is false, right? And then we can just break out of here. Yeah. Because when we break out of here, we should also end this. No, we shouldn't. How are we gonna break out of nested for each? See what Google says. It just wants us to return from a function. Which we could do. Say if bullet dot. I don't know, because this is going to be for different bullets. Okay. Okay. I don't think we even need this break, now that I'm thinking about it. So every bullet, we're going to check for every enemy. If it touches an enemy, then we no longer need to process enemies for this bullet. So we would need to break. Can you break out of for each JavaScript? Says you cannot use break. If we need to end early, we should loop a different way. But I don't want to. Alright, well, an easy way to do this is just say if bullet is alive, then we want to do this check. Because if the bullet has already hit an enemy, it won't be alive anymore. So then we'll just loop through the remaining enemies and we'll say that, well, the bullet isn't alive because we said it's not alive anymore. So we're not going to process this information. So we're just going to leave a lot sooner without actually doing this calculation. So not super optimized, but it'll work for our purposes. And then we also need to let's only update enemies and stuff if they're alive. Enemy is alive, then we'll do this. That'll save us some performance. And then if bullet is alive, then we'll do this. That'll save some performance. Yeah. Now the thing is, we should be able to, I believe, shoot an enemy, and the bullet and the enemy should disappear. I think I'm noticing something though. Yeah, even when the enemy and bullet are not alive, it's checking the collision. So we need to say if the bullet is alive and the enemy is alive, then we'll do the collision. So now I should be able to hit something and it should only consume one bullet. And the other ones should continue flying. And it looks like that's what's happening, at least from what I can see. So that's good. Now we need to limit the number of enemies there are in some way. Because if we keep shooting them, they're just gonna disable. I want to do some kind of shift thing similar to what we did with bullets. But I don't know what the max number of enemies on screen should be. I think an easy way we can probably test that is when we go to spawn an enemy. Here. Then we say if enemies.length is greater than 100. We'll kind of test it out similar to a bullet. Then we'll say enemies.shift. Okay. Now we just need to see if the enemies will eventually touch us. Because if they all have the same speed towards us. So if they're able to touch us, then we know that we have enough live in order to play the game properly. So they can touch us now. Let's try like 20, see if that will demonstrate kind of what I'm trying to show. So this one's going like right at us. It's the first one we saw. So if this disappears before it touches us, we'll know there's more than 20. And it did. It vanishes just before it touches us. So if we said like 30, then now we know that we can have enough on screen in order to lose the game. But we don't have so many that we're wasting valuable memory, right? So it touched us right there, which means we can lose the game, which means we have enough in memory. Okay. So let's talk about the game a little bit. Like right now, I feel like we can just spam the crap out of bullets like this and we just clear the entire screen. And that's way too easy, right? So we either need to spawn more enemies, which I don't think will solve this problem. We need to make enemies move faster, which I don't think will solve the problem. We need to make it so you can't shoot as often, which I think could solve the problem. Or or basically we give the enemies health, which is probably the most gameplay fun thing we can do. Let's do that. I don't think that'd be too hard to add at this point. And I like shooting a lot of bullets per second, so I don't really want to limit that. So let's say enemy. We'll say at the top, this dot health. We'll try like 10 to begin with. And then when we do a collision with it, we don't want to say immediately that the enemy is not alive. We want to say if the enemy dot health is less than or equal to 0, then the enemy's no longer alive. And then if it touches, we want to say enemy dot health minus minus. So it'll take a damage, and then if its health is gone, it will disable, right? So now I should have to shoot an enemy a couple of times. I'll let it get closer so we can kind of count 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, eventually it dies. So I can shoot little spits at it, and it doesn't go away, but eventually it will, right? So now I have to actually kind of point at an enemy for a couple of seconds, like a couple milliseconds before it will actually kill the enemy, right? And I think we should raise this number a bit because this still seems a bit too easy. So let's raise the health to like 100. That should make it significantly more difficult to get them all. Okay, so just kind of playing the game normally. That took some time. So I'm gonna have to kind of lead my bullets a bit in order to actually clear them. I feel like they're gaining on me a little too quickly right now. Like this may be a little too difficult. Eventually they're gonna get me, and there's nothing I can do about it. So let's try 50 health. we're just kind of jumping around numbers, seeing what feels good, right? So if I'm just playing this game, that one's going fast. And why I wanted the variable speed that it was coming and going is because it's going to change how much you need to lead the shot, right? So it's kind of hard to tell which ones are closer to you sometimes because they're orbiting at different speeds. And then also, you're going to have to lead your shots differently depending on the orbit speed, right? Oh. Okay, they're getting pretty close. But this seems pretty good, honestly. Like, I think we lower the health just a little bit more, and this would probably be playable, like, infinitely, which is kind of what we're going for this game design. So, I mean, I think I've been touched once, but I would definitely I would get got pretty soon, I think, here. Oh! I think we lower the health just a tiny bit. Okay. So let's do like 40. I feel like that would definitely be playable. So now we have a limited number of bullets, a limited number of enemies. We can kill the enemies. The enemies have health. We need to make it so the enemy can kill us. So we need to say player, and we'll say is alive. And that's going to be true to start out. Let's go to render. We're going to say for the player, if player dot is alive, then we'll draw the player. And then we need to say for shooting bullets, which is down here. I knew we were going to do something again. So if the player is shooting and the player is alive, then we'll make new bullets, right? Because we don't want a dead player shooting enemies. That wouldn't make sense. Then we need to do a collision between the player and the enemy so we can toggle the player's value. So we need to say player. No. We're going to say enemies for each enemy arrow. If we're going to use our distance formula again. If the distance between enemy dot x, enemy dot y, player dot x, and player dot y is less than or equal to player dot radius plus enemy dot radius. And I will break this up so it's easier to see. So if the distance between these two things is less than or equal to the radius of them both, then they're colliding, right? And we'll say player is alive is false. And then I just want a, like, if player.is alive thing, so we're not constantly looping through this even when the player's dead. Probably doesn't matter, but I'll do it anyway. It'll save some processing if you're like AFK. So we will not draw the player anymore if the player has died. How about we say, let's make a, like, spawn enemies kind of toggle. And we're only gonna spawn enemies if that's true. If their timer is here, mm, I mean, I guess that's probably fine. And spawn enemies. Spawn enemies. So if the timer is up and we are spawning enemies, then we will spawn an enemy. But if we get touched by an enemy, we're gonna say spawn enemies is false. So we don't want to spawn enemies anymore if the player gets touched. And what that should look like is if I just like AFK and let them touch me. Do, 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 do. Boop. Okay, we disappeared, and that should stop the spawning of enemies. And eventually, they'll all kind of get deleted because we're not deleting them. Okay. Let's just say enemies dot empty, I think is the correct function. Okay. So we're not going to spawn enemies anymore, and we're also going to empty the enemies array so there are no enemies anymore. This guy is going to get us. Boom. Okay. Enemies.empty is not a function. Empty array JavaScript. You can set the length? That's crazy. If I do that, it clears the array. That's interesting. Because it says I could just make a new array, which I already knew. And I think we did in Cube Wars. But this says I can just change the length and it'll like adapt to it. Boom, like everything clears and we don't have any errors, right? So at this point, we would have like a you suck, you're bad at the game, whatever, right? So that's good. So here, we can really put this anywhere because we're not drawing anything else, but I'll say lose screen. We'll just say if player dot is alive. If the player is not alive, then we want to say can dot set font. It's gonna be, this is not how we do this, is it? I think it's like font style, something like that. Change font canvas JavaScript. Shit, it's just font. And we'll try like Times New Roman. And it'll be like 40 pixel. I did this in the wrong order. 40 pixel Times New Roman. Bold. I had it right to begin with. I'm like dyslexic. Bold Times New Roman 40 pixel. Nope. 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 Bold 40 pixel Times New Roman. Is that good? Yep. I'm dyslexic. And then can dot draw string, I believe is what it is. We'll just say like 30, get it on the screen. We'll do like 100. We want the text to be you lose. Okay. And we need to say can dot fill style is red. Okay. So now if we lose, we should get some text that says we lose. Technically, there's not going to be a victory in this game. The game will go on forever. DrawString is not a function. It's probably draw text or fill text. If I had to guess, it's probably fill text. Fill text. I'll Google it while we wait. Fill text. JavaScript. Yep. Fill text. Oh, you can do a max width. That's interesting. Okay, we got you lose. Maybe do Arial instead, or even monospace. Monospace is fun. Let's make it bigger. Let's say it's like 80 pixels. And then we'll do probably further down the page. Try like 300. See where that goes. Boop. We lost. Okay. So we need to get further in and further down. Let's try like a 500 and we'll try like a 150. Obviously, I'm just being kind of nitpicky about this, but I do think presentation matters in a game, so it's not exactly a waste of time or anything. Boop. Okay, so maybe up a little bit. Let's do like 450. And we still need to move this. Let's try like 300. I'm in danger. Boop. Okay. Left a little bit. Maybe like 250. I don't think we tried that before. Okay. Just waiting for them to touch us. Boop. Alright, that's reasonably centered. Now, we need kind of a goal, right? And I think I said before, but your goal is to like live longer. Like you're trying to last forever, essentially is your goal, right? So let's make a like score. I think I'll just make it a global thing. Let score equals 0. And then I want to increase the score every second. And I could just throw that in the update, which I may do. But I also need a score counter. Let score counter also be 0. So in update, we're going to do all this stuff. And if you're still alive, score counter is going to increase. So if player is alive after everything, we're going to continue playing the game. And then if score counter is ever greater than or equal to 60, we're going to score plus plus. And then score count equals 0. It's basically every second that you're alive, we're going to increase the score, right? And then when you die, we're not increasing the core or the counter anymore. So the counter is never going to be greater than 60. So you'll stop increasing your score and you'll be done. So then we need to draw the score on the screen. So let's go down here where we're drawing this you lose text. And we can say a similar thing, but we don't need a condition on it. So fill style equals, we'll say black. And then font is a bold, like 40 pixel monospace. Can fill text. Oh my gosh. Score plus score at we'll say like 15 and 40. We're kind of guessing. And let's check that out. Okay, so every second your score goes up. And let's maybe just change this to say like seconds alive or something like that. Maybe just alive, and then we'll put an S after. That's supposed to be a plus. Okay, so you've been alive for this many seconds. Let's even add a space here. Kind of give it a bit of padding there. So now you have something that you can stare at to know how well you're doing. And you can defeat enemies. And then eventually, you're going to be like, oh no, I missed one. And your counter is not going to go up anymore. So you lost the game. You're alive for 29 seconds. And that's kind of the gist of the game. Is you're supposed to play it with your friends, see which one of you can last the longest. And then I think I'm gonna do some color adjustments. I think we're gonna make the background, let's try like a gray for the canvas. And we're gonna have to choose a brighter color for the bullets. Try kind of a custom color. I want something dark. We'll try like 555555. Maybe a little darker than that even. Okay. This is alright.